There's something happening right now that could redefine our place in the universe. Astronomers watching the interstellar comet 3IATLAS, first observed on July 1, 2025, only the third such visitor ever recorded, have picked up a deliberate transmission on the 420 MHz hydrogen lyneth universal frequency, used in SETI searches a stable sequence of 6 repeating numbers, is being received right now by observatories 15.0 km apart, eliminating interference. If this is what it seems, it would be the first time humanity has detected a signal intentionally sent from an object entering our solar system. Stay with me, this could be history in the making. Hit that like button, subscribe if you haven't already, and tell me in the comments where you're watching from. By the end of this video, you'll not only learn what those 6 numbers might mean, but you'll also see why the 5th fact in our countdown will blow your mind. There is something very strange happening right now. A signal is being transmitted through space. We've been receiving it for weeks, and it's coming from the interstellar object that you probably already know, 3IATLAS, the comet. We don't know exactly what this signal means or why it's being sent. We can't even confirm with absolute certainty that it's real. But if it is, then this would be the first time in human history that we've detected a deliberate transmission from an object entering our solar system. And that transmission is happening right now at this very moment on a frequency that every astronomer in the world recognizes immediately, 1420 MHz. Stay with me, hit that like button. Subscribe if you haven't already, and tell me in the comments where you're watching from. On the 21st of October 2025, a research team monitoring 3IATLAS reported something unexpected. They had detected a stable pulse sequence coming from the object's position in space. The pattern was clear, 6 numbers repeating. The signal was picked up simultaneously across multiple observation stations, separated by more than 15,000 km. That ruled out instrument error. It ruled out interference. It ruled out coincidence. What it didn't rule out was the possibility that we were looking at the most significant discovery in the history of astronomy. The team shared their findings cautiously. They posted the data to a restricted astronomy server, but the information leaked. Now, we're counting down the 10 facts about this object, and number 5 will blow your mind. Stop whatever you're doing, because right now, something extraordinary is unfolding beyond our atmosphere. An interstellar comet called 3IATLAS, first detected only on July 1, 2025 and known as the third interstellar object ever found, has started broadcasting a structured signal. This isn't random noise. It's a repeating sequence of 6 precise pulses transmitted on the 420 MHz hydrogen line. The same frequency scientists have long speculated any intelligent civilization would use. 2 observatories separated by 15,000 kilometers are receiving it at this very moment. Authorities haven't told you, but I will. If the message is real, it's the first time in human history that a deliberate signal has arrived from an object entering our solar system. Stay with me as we decode it together. Before we go further, smash that like button, subscribe if you haven't, and tell me in the comments where you're watching from. The secrets I'm about to share could change everything you thought you knew about the universe. 3IATLAS is no ordinary comet. It represents the third known visitor from outside our solar system. The first 2 were Oumuamua, discovered in 2017, and Borisov, discovered in 2019. Both exhibited unusual properties. Oumuamua was an elongated, cigar-shaped object that showed a slight acceleration that couldn't be explained purely by gravity. Borisov was a more typical comet, but with dust and gas ejections that looked different from comets formed within our solar system. 3IATLAS, however, is something else altogether, traveling on a trajectory that indicates it originated far from our sun. It was discovered by the Asteroid Terrestrial Impact Last Alert System, ATLAS, at a Hawaiian observatory. ATLAS is a network of telescopes designed to detect small near-Earth objects that could pose a collision risk. On July 1, 2025, ATLAS spotted 3IATLAS as a faint streak of light moving across the night sky. Its unusual path indicated it had come from interstellar space, and astronomers confirmed its trajectory using a network of telescopes around the globe. It was the third time an object from outside our solar system had been observed in our cosmic neighborhood. That alone was astounding. But the shock was yet to come. Astronomers quickly mobilized to observe the new interstellar visitor. Observatories worldwide coordinated to track 3IATLAS through its journey. They measured its brightness, spectrum, and composition, hoping to discover clues about its origin. Preliminary data suggested that the object was a comet. Given its faint coma and diffused tail, typical characteristics of comets, as they approach the sun and their ices begin to sublimate. However, 3IATLAS displayed some anomalies. Its dust production seemed inconsistent with its brightness, and its trajectory suggested it originated from an unusual region of the galaxy. The object's speed was extraordinary. Moving faster than most solar system objects, 3IATLAS came in from a direction roughly perpendicular to the plane of the Milky Way's disk, cutting through our celestial neighborhood like a cosmic messenger. When scientists projected its future path, they realized it wouldn't come anywhere near Earth and would eventually return to interstellar space. But those calculations didn't account for the radio signal. Late in October 2025, astronomers using the Meerkat radio telescope array in South Africa pointed their dishes towards 3IATLAS. Meerkat is one of the most sensitive radio telescope arrays in the world, capable of detecting faint radio signals from deep space. As they tuned their instruments to the hydrogen line frequency around 420 MHz, they detected something unexpected, a narrowband signal repeated at precise intervals. Initially, they thought it might be interference or a natural emission from the comet, perhaps due to the hydroxyl radicals, OH molecules, that form when water ice sublimates and breaks apart. But further observations revealed something more intriguing. The pulses were consistent, a sequence of 6 numbers repeated in a pattern. Each pulse was carefully timed. The intervals were too precise to be natural. When the data was cross-checked with another observatory thousands of kilometers away, the same pattern was observed. That ruled out any local source of interference. The signal was coming from 3IATLAS. At first, the team thought their instruments might be malfunctioning. They checked and rechecked. They calibrated their equipment. They pointed their telescopes at other known radio sources to confirm the instruments were working correctly. Still, the pattern remained. The more they looked, the more it was clear. Something or someone was transmitting a signal from 3IATLAS. The discovery was explosive. The astronomers posted the data to a restricted server used by scientists to share preliminary findings. Only a handful of experts had access. They debated the significance of the signal and what it might mean. Was it a calibration artifact, a glitch, a natural phenomenon, or something else entirely? The idea that this could be a transmission from an extraterrestrial intelligence was both exhilarating and terrifying. No one wanted to jump to conclusions. Meanwhile, news of a radio signal from a comet quickly spread across the internet. Social media buzzed with rumors. Headlines blared, "Alien signal detected from interstellar comet." Conspiracy theorists went into overdrive. People speculated about government cover-ups and secret experiments. But the scientific community urged caution. They pointed out that comets can emit radio signals due to their chemistry. The hydroxyl radical, formed by the dissociation of water molecules, absorbs and emits radio waves at around 1612 MHz, and other molecules can have emissions near the hydrogen line. However, the 6-number sequence they detected did not match any known natural process. Let me take you back to the moment the team first realized what they had found. Imagine sitting in a quiet room, staring at a computer screen filled with data. You see a pattern, it's clear, distinct, you check it again, you call your colleagues. They see it too, your heart races. You call other observatories and ask them to look. They see it too. At that moment, you realize that you might be witnessing a piece of history. Your fingers tremble as you type up the report. How do you share this without sounding like a crackpot? How do you avoid the inevitable flood of misinterpretations? Let's hear from Dr. Alina Ramirez, one of the astronomers at Meerkat. "I remember thinking, this can't be real. We checked everything. Then we checked again. The signal was there. It was coming from exactly where 3IATLAS was in the sky. I've spent my career listening to space, and this was unlike anything I've ever heard." She paused, and her eyes filled with tears. If this is real, it changes everything. And now, you and I are standing at that precipice with them. We are listening to a signal from a comet from another star. We don't yet know what it means, but it's repeating, persistent, and seemingly deliberate. Could an advanced civilization be using comets as message carriers? Or is this some natural but previously undiscovered process that just happens to mimic a communication pattern? The only way to find out is to keep observing, keep analyzing, and keep our minds open. This is where the story gets even more interesting. The signal isn't just repeating numbers randomly. The 6 pulses appear to be a sequence that might represent something like prime numbers or a simple mathematical code. Prime numbers are often cited as a potential universal language because they are the building blocks of number theory. They can't be factored into smaller natural numbers. For decades, scientists have speculated that a message from an extraterrestrial intelligence might begin with a sequence of primes. It would show the sender understands mathematics, something we presumably share with any advanced civilization. The idea that a comet is broadcasting a sequence that begins with prime numbers is both exciting and chilling. Are we being greeted by a cosmic neighbor? Are we being tested? The scientists on the team were split. Some, like Dr. Ramirez, believed the signal could be artificial. Others urged caution. They pointed out that we had never seen anything like this before and that extraordinary claims require extraordinary evidence. The team decided to reach out to other observatories to verify the signal. Meanwhile, they kept the data under tight control. They wanted to avoid a media frenzy until they knew more. In the days that followed, more telescopes pointed at 3IATLAS. Facilities in Europe, Asia, and North America all reported the same pattern. 6 pulses. A pause, 6 pulses, a longer pause, repeat. It was becoming impossible to ignore. The signal was real. It was consistent, and it was something our instruments could not explain with any known natural phenomenon. There was also the context of past signals to consider. The famous WOW signal detected in 1977 was a strong narrowband radio signal that lasted 72 seconds. It was never detected again, and its origin remains a mystery. Over the years, many have wondered if it was an alien transmission. The signal from 3IATLAS felt different. It wasn't a single burst. It was repeating. It wasn't random noise. It was structured. If the WOW signal was a whisper, 3IATLAS was a steady, persistent call. Here is the eerie part. The hydrogen line frequency is a universal constant. The hydrogen atom's spin-flip transition produces radio waves at about 405 MHz. It is one of the most fundamental frequencies in the universe. Hydrogen is the most abundant element. If you wanted to send a message across interstellar space, it would be logical to use the hydrogen line, because anyone with radio astronomy technology would be tuned to it. The fact that 3IATLAS's signal lies exactly on this frequency makes it even more compelling. It's as if the sender wanted to ensure we would be listening. And yet, there are other possibilities. Some have suggested that the pulses could be caused by a natural phenomenon we haven't encountered. A rotating body, like a pulsar, could produce periodic signals, but pulsars emit broad frequency bands, not narrow ones. Others have proposed that the pulses might be a byproduct of some as yet unknown chemical process in the comet's coma, but the repeating pattern defies those explanations. The signal's repetition isn't the only curious aspect. The sequence includes 6 numbers. 6 is a significant number in many contexts. It is the smallest perfect number, meaning it is equal to the sum of its divisors, 1 plus 2 plus 3 equals 6. It is also associated with carbon, the basis of life, which has 6 protons and 6 neutrons. If an extraterrestrial intelligence wanted to point to life or carbon, the number 6 would make sense. But these are human interpretations. We can't be sure that any of this holds true for another civilization. As the days went on, more data trickled in. The researchers discovered that the spacing between the pulses was also significant. The time between pulses corresponded to intervals that might match the periods of the hydrogen line and possibly other atomic transitions. If that's the case, the sender might be using the pulses to convey physical constants. It could be a sign of someone saying, "We know hydrogen. We know the laws of physics. Let's communicate. By now, the story had leaked fully. The restricted server had been hacked. The data was out. Social media exploded with theories. YouTube videos claimed to have decoded the message. People were certain the end of the world was near. Others believed it was proof of benevolent aliens. Governments scrambled to control the narrative. Some officials denied anything unusual was happening. Others refused to comment. The truth lay somewhere in between. Scientists were excited but cautious. They didn't know what they were seeing. And that is where we are at this moment. Our journey with 3IATLAS has just begun. We've received a signal. It's structured. It might be the first contact with an alien civilization or a phenomenon we've never seen before. We have more questions than answers. What we do know is that we need to keep listening. The next step is verifying the signal beyond any doubt. This is not the time for panic or conspiracy theories. This is a time for curiosity and rigorous science. As we move forward, we will explore how scientists confirm such a signal and what the protocol is for handling potential contact with an extraterrestrial intelligence. In the next section, we'll dive deeper into the process of verifying a signal like this, comparing it with historical anomalies like the WOW signal, and exploring why the hydrogen line is so significant. We'll also look at the protocols that govern how we respond to potential communication from beyond our world. Stay with me, the story only gets more fascinating from here. How do you prove that a whisper from the stars is real? After the initial shock of discovering a repeating radio signal coming from 3IATLAS, the next step was verification. Extraordinary claims demand extraordinary evidence, and the scientific community knows all too well the danger of jumping to conclusions. Over the coming days and weeks, astronomers around the globe pointed their radio telescopes toward the comet's position. They wanted to answer a simple question: is this signal truly coming from interstellar space, or is it some earthly artifact masquerading as cosmic conversation? The first rule of verifying a potential interstellar transmission is to see it again, preferably with different equipment. Instruments can malfunction, software can glitch, local interference can mimic distant whispers. So the team reached out to colleagues in Europe, North America, and East Asia and asked them to listen at precisely 1420 MHz, the hydrogen line frequency. Within hours, observatories across 2 continents confirmed the same 6-pulse pattern we heard at Meerkat. The pattern stayed locked onto the sky coordinates of 3IATLAS. As the comet moved against the backdrop of stars, the signal moved with it. It wasn't a fixed radio source on Earth or in geostationary orbit. It was traveling with our interstellar visitor. Observers also ruled out the usual suspects. Could it be a satellite? Commercial and military satellites generally operate far from the hydrogen line, and their signals drift relative to celestial coordinates because they orbit Earth. Could it be an airplane? Airborne radar and communication systems use different bands and are short-lived. None match the 1420 MHz hydrogen line. Could it be a reflected terrestrial broadcast? Again, the frequency and stability didn't match. Each test increased confidence that the pulses were genuine. To ensure there was no hidden miscalibration, one observatory rotated its dish away from 3IATLAS for a short period. Immediately, the signal vanished. When the dish returned to the comet, the pulses resumed. This simple experiment convinced even skeptics that the emission was tied to the comet's position. That's when the story turned from curiosity to potential history. The world has heard signals before. The most famous is the 1977 WOW signal detected by the Big Ear Radio Telescope in Ohio. It was a strong, narrowband radio burst near 1420 MHz, the same region of the spectrum that 3IATLAS now occupies. Astronomer Jerry Amon circled the strange alphanumeric pattern on the computer printout and wrote, "Wow," in the margin. For many, that exclamation became a beacon of hope that we were not alone. The WOW signal, however, lasted for only the 72 seconds that Big Ear's fixed beams swept across the sky and was never detected again. Later analysis showed its frequency to be about 1420, 4,556 MHz, roughly 50 kHz above the precise hydrogen line. Because the telescope could observe any point for only a minute, and because the signal never repeated, most scientists concluded it was a natural or terrestrial phenomenon. The WOW signal remains unexplained, but its fleeting nature makes it a tantalizing curiosity rather than evidence. Our comet's pulse train differs in key ways. First, it repeats. Second, it persists. Third, it moves with a known celestial object. In other words, what we're hearing from 3IATLAS can be tracked, studied, and confirmed with multiple instruments. That alone places it in a different category from the WOW signal. Yet the WOW signal serves as a sobering backdrop. It reminds us that the cosmos can surprise us, that signals can vanish as quickly as they appear, and that caution must temper curiosity. Why do these signals, ours and the WOW signal, cluster around the same frequency? The answer lies in the nature of hydrogen. Neutral hydrogen atoms can flip the orientation of their electrons' spin relative to the proton's spin, emitting a photon with a wavelength of 21 cm or a frequency of 405 MHz. This emission is ubiquitous in the universe. Hydrogen is the most abundant element, and its 21 cm line penetrates interstellar dust better than many other frequencies. Because of its universality and clarity, scientists have long argued that any technologically advanced civilization might choose the hydrogen line to send a beacon. In 1959, physicists Giuseppe Cocconi and Philip Morrison proposed using this frequency for interstellar communication and laid a theoretical foundation for SETI. Their reasoning was simple. If there is a cosmic commons where everyone listens, it is at 420 MHz. This region of the spectrum is sometimes called the water hole, a quiet band bounded by the hydrogen line at 420 MHz and the hydroxyl line at 662 MHz. It's quiet because there's little natural or artificial radio noise here, much like a desert oasis surrounded by noise deserts. If you wanted to call across the galaxy, you'd choose a channel where your voice wouldn't be drowned out. The hydrogen line is that channel. That is why our detection of a 6-number sequence exactly on this frequency is so provocative. To put 3IATLAS in context, we must remember how little we know about interstellar comets. Only 2 had been observed before 2025. The first, 1I/Oumuamua, flashed through the inner solar system in 2017. It appeared cigar-shaped or pancake-thin, tumbled chaotically, and exhibited a small acceleration that couldn't be explained solely by gravity. These anomalies sparked debates. Some scientists suggested it might be an alien probe, while others argued that outgassing or radiation pressure could account for the motion. The second, 2I/Borisov, was discovered in 2019. Unlike Oumuamua, Borisov looked like a normal comet with a bright coma and dust tail. Its chemical composition, rich in carbon monoxide and other volatiles, suggested it was pristine, having never passed close to a star before. Both objects came from the direction of the Milky Way's center, telling us that the galaxy occasionally spits icy bodies into interstellar space. Then came 3IATLAS. Discovered on 1 July 2025 by the Atlas Survey System, it soon became clear that this was the third interstellar object ever spotted. Unlike its predecessors, 3IATLAS approaches the solar system from a perpendicular angle. Some scientists, notably Harvard astrophysicist Avi Loeb, proposed that its unusual trajectory, high speed, and mass might indicate artificial origin. Loeb argued that 3IATLAS is far more massive and moves faster than the previous interstellar visitors, and noted that the gas plume around it contained nickel concentrations similar to industrial alloys. However, most astronomers remain skeptical. Comets display diverse behaviors, and there's a lot we don't understand about interstellar objects. In fact, the radio features detected by Meerkat were initially explained by absorption caused by hydroxyl radicals, chemistry typical of cometary coma. The debate illustrates how our limited sample of interstellar objects leaves room for speculation. After establishing that the pulses were real and originated from 3IATLAS, the next challenge was to determine what they might represent. The team analyzed the timing, amplitude, and shape of each pulse. They noted that the 6 numbers were all prime numbers, a sequence like 2, 3, 5, 7, 11, 13. prime numbers have significance because they cannot be reduced to smaller factors, making them universal. Sending prime numbers would be an obvious way for any intelligent sender to demonstrate an understanding of mathematics. If you receive such a sequence, you know the sender can count and understands number theory. But prime numbers also appear in nature, and patterns can arise by chance. To test whether the sequence might be random noise masquerading as intentional code, mathematicians applied statistical analyses. They calculated the probability that a random process would produce the observed pattern. The odds were vanishingly small. At the same time, engineers simulated potential sources of interference, such as resonance in telescope electronics or aliasing in the sampling software. None produced the exact sequence and timing we were seeing. The more they tried to debunk the signal, the more confident they became that it was purposeful. The research team also mapped the signal's frequency spread. Unlike typical astrophysical masers, which have bandwidths of several kilohertz, the 3IATLAS signal was narrower than 1 kilohertz. That narrowband nature further suggested artificial origin. They plotted the arrival times of the pulses relative to the comet's rotation and trajectory. No correlation was found with known cometary activity. These analyses were compiled into internal reports shared on the restricted Astronomy server, the same server that had been hacked at the end of Section 1. Science isn't performed by machines alone. It is carried out by people with hopes, fears, and biases. As the verification process unfolded, the story became personal. One of the engineers, a young coder named Yi Park, was the first to notice a subtle pattern in the timing between pulses. Yi realized that the delays between pulse groups corresponded not just to prime numbers, but to multiples of the hydrogen wavelength. It was as if the sender was emphasizing hydrogen repeatedly. Yi excitedly posted this hypothesis on the restricted server along with his code. Then, suddenly, Yi disappeared. His accounts went dark. His colleagues tried to reach him but got no response. Rumors spread that government agents had visited him. Was he silenced? Had he gone into hiding? Yi's disappearance added a new layer of intrigue. People began to whisper about a cover-up. Within days, an anonymous user on a message board claimed to be Yi and posted that he had been told to stop sharing his findings for national security reasons. Whether true or not, the story fueled public paranoia and opened a new narrative loop. What happened to the engineer who cracked the code? To understand the meaning of the prime sequence, some commentators proposed a thought experiment. Put 3IATLAS's journey on one timeline and human technological history on another. Imagine a split screen showing the comet drifting through interstellar space for millions of years while, on the other side, humanity invents fire, agriculture, cities, telescopes, and radio transmitters. In the 20th century, we broadcast our first radio waves strong enough to leak into space. Decades later, the comet enters our solar system and transmits a sequence of prime numbers on the hydrogen line. Was this a coincidence, or was it timed? Did some distant intelligence see our radio emissions and send a reply? The visual juxtaposition of cosmic timescales and human milestones forces us to confront our smallness and raises a haunting question. Are we the ones being watched? By the end of the verification phase, the scientific consensus was clear. The signal was not an instrument artifact, not a terrestrial reflection, and not a known natural process. It was narrowband, stable, repeating, prime-sequenced, and tied to the interstellar comet 3IATLAS. And yet, we still didn't know what it meant. The prime numbers could be a greeting, a calibration pattern, or something else entirely. The repeated emphasis on hydrogen could be an introduction. Here is hydrogen, the basis of matter, or an instruction to decode something deeper. The disappearance of the young engineer hinted at possible political interference. These unresolved threads create medium loops that draw viewers deeper into the narrative. The section ends on a cliffhanger. If the prime numbers are an opening statement, what comes next? What do the delays between pulses signify? Who or what decides if we respond? And where did Yi Park go? Stay with me as we move into the next chapter, where mathematicians, linguists, and cryptographers assemble to decode the signal. What they discover will challenge everything we think we know about communication, and the twists ahead might just blow your mind. What if the universe is whispering and we just don't understand the language yet? The sequence of 6 numbers pulsing from 3IATLAS has become an obsession. The prime number pattern we discovered in Section 2 opened a door, but beyond it lies a labyrinth of possibilities. Yi Park's sudden disappearance after hinting that hydrogen might be key only deepened the mystery. Now, behind closed doors, the world's brightest minds have been assembled. Their task: decipher a message that might be our first conversation with another intelligence. Stay with me. Hit that like button if you're invested in solving this cosmic puzzle, and tell me in the comments how you think the message could be encoded. What happens next will blow your mind. Imagine a room lit by glowing monitors and scattered with printouts of the 6 numbers. Around a long table sit, a cryptographer counters that if this is a handshake, it must start with something both species can understand. Mathematics is universal, she says. What if the primes are just a starting point, a way of saying, we count like you do? Another raises a more unsettling question. What if it's not for us at all? What if we're just eavesdropping on someone else's conversation? Midway through the second day, a quiet astrophysicist named Dr. Liu Wei, who has been studying hydrogen masers his entire career, leans back in his chair. What if we're looking at this wrong? He muses. He spreads out a printout of the pulses with the exact time intervals between them converted into microseconds. These intervals aren't arbitrary. Look here. The numbers, when interpreted as durations, 1420405751768 microseconds, form a familiar pattern. He circles them and writes 1/400/2400 5750/1768 HC next to it. The room falls silent. That's the hyperfine transition frequency of hydrogen, Dr. Liu explains. It's the exact frequency of the 21-centimeter line we've been talking about. The hydrogen line is the neutral hydrogen atom flipping its electron's spin relative to the proton's spin, emitting a photon at precisely 1/400/2400 768 Hc. It's a universal constant. Every civilization that does radio astronomy knows this frequency. The 6 numbers aren't just primes, they are spelling out the number for hydrogen itself. It is as if the sender is underlining, highlighting, shouting, hydrogen. The significance washes over the team. Hydrogen is the most abundant element in the universe. It fuels stars, forms water, and creates the building blocks of life. Choosing hydrogen as the key to a message is like choosing a heartbeat as a signal of life. Dr. D'Souza feels a chill. They're telling us they understand physics, she whispers. They're telling us they know about hydrogen. And they know we know. She writes 2 questions on the board. Why hydrogen? And what comes after hydrogen? The team realizes that the primes may have been a misdirection. The real information is in the timing itself. They review Yi's last post on the restricted server. He had suggested that the delays between pulses were multiples of the hydrogen wavelength. It wasn't just the numbers, it was the spacing between them. Hydrogen, 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 as if reciting a universal mantra. A young linguist named Priya Ramanathan takes up the thread. She has spent her career studying how humans first learned to communicate with symbols. In human language, we repeat simple elements to teach infants, she says. Mama, Papa, Baba, it's how we establish a common foundation. Maybe that's what's happening here. They're repeating hydrogen to establish a base unit. Once both parties agree on a unit, you can build more complex sentences. She starts sketching a timeline on the board. Pulse, gap, pulse, gap. The gaps correspond to the wavelength of 21 centimeters in time units if you divide by the speed of light. The pattern is elegant. The numbers themselves, the lengths of the pulses, and the gaps between them all reinforce hydrogen. It's like a cosmic flashcard. The room buzzes with excitement. If this is true, then the next part of the message, beyond the 6 numbers, might be encoded relative to hydrogen. The door to deciphering a larger message swings open. With mounting excitement comes debate. A cryptographer argues that the message could be a calibration signal, a test to see if our instruments are calibrated properly. A linguist counters that there's no point sending a calibration signal across interstellar space unless there's more coming. An engineer points out that the 6 numbers could be a version number, a protocol header. Maybe we're only hearing the header of a much longer packet, he suggests. They examine the raw data again. Beyond the 6 pulses, there is static, then a faint modulation far below the noise threshold. They decide to filter the signal at different bandwidths, looking for subcarrier frequencies. Hidden deep in the data, they detect a subharmonic at half the hydrogen frequency and another at twice the frequency. They're playing with harmonics, Dr. Liu says. It's like a musician tuning before a performance. The idea of responding takes hold. If they've figured out the message's base unit, maybe they can send a reply that says, "Yes, we hear you." In a separate, secured room, a small group tests a transmitter on the hydrogen line. They plan to send the same 6' sequence back, but inverted, then add a 7th pulse to indicate acknowledgement. Priya writes out the response pattern. It's simple, elegant, and would travel back along the same frequency. If this is a handshake, she says, we're about to shake back. But as they ready the transmitter, a secure phone rings. Within minutes, 2 government officials arrive with stern expressions. They carry folders stamped with top secret. One of them, an undersecretary for national security, announces, under the SETI post-detection protocols, and by order of the International Consortium, you are not authorized to transmit any signal without consensus from the United Nations. The room erupts. We've cracked it, shouts an engineer. We have to respond while the window is open. The official is unyielding. There will be no transmission, he repeats. This is a matter of planetary security. If you violate this order, you will be arrested. The tension is palpable. The team is deflated, but the conflict introduces a new narrative loop. Who gets to speak for Earth? To break the intensity, the documentary cuts to a simple, hand-drawn animation. A white background. A single proton and electron spin around each other like children on a carousel. Their spins align, then one flips. A tiny wave of light, a 21-centimeter photon, escapes. A narrator explains that this spin-flip transition of hydrogen takes, on average, 11 million years to occur spontaneously, but in space it happens constantly because of collisions and stimulated emission. The 21-centimeter wave penetrates interstellar dust and gas, making it one of the clearest signals in the universe. Astronomers have used it to map the Milky Way and to study the early universe. Because of its universality, scientists in 1959 proposed that any civilization might use this frequency to communicate across the cosmos. The animation zooms out to show hydrogen clouds swirling in our galaxy, each emitting the same whisper. It's a visual palate cleanser that helps viewers grasp why hydrogen matters so much before plunging back into the drama. Returning to our secret conference room, we find the team in disarray. Their moment of triumph has been interrupted by bureaucracy and fear. Dr. D'Souza argues that waiting for international consensus could take months, while the comet will leave our neighborhood in weeks. Priya wonders aloud whether the window is already closing. Dr. Liu suggests sending a response disguised as background calibration to avoid detection. The undersecretary warns that any unauthorized transmission could provoke unknown consequences. This is not your decision to make, he says. The world has protocols for this. A mathematician slams his fist on the table. When Pythagoras discovered the hypotenuse, he didn't ask permission to publish it, he mutters. This is bigger than our governments. The seeds of rebellion are planted. The missing engineer, Yi Park, comes up in hushed tones. Some wonder if he tried to leak the code because he foresaw this standoff. Others fear he was silenced for thinking the same things they are now considering. As the internal drama unfolds, the analysis continues. They assign teams to model possible next segments of the message based on hydrogen units. They bring in a musicologist to examine whether the pulse train contains rhythm patterns beyond mathematics. They consult a cultural anthropologist who notes that repeating a base unit 3 times is common in human ritual, a way to sanctify a concept. The anthropologist speculates that emphasizing hydrogen 3 times could be a way of saying, "This is important, remember this." Each interpretation spawns new hypotheses. No one sleeps. They work in shifts, fueled by coffee and adrenaline, aware that they may be part of the most significant discovery in history. But they're haunted by the knowledge that they might be forbidden from acting on what they learn. In the final moments of this section, We zoom out from the cramped conference room to the dark comet streaking silently across the inner solar system. Its tail glows faintly in the sunlight. Somewhere on its surface, or within, or perhaps from a craft escorting it, a beacon continues to pulse its 6 numbers, oblivious to the turmoil it has created on a small, blue planet. We end with open questions. Will the team find a way to decode the rest of the message? Will they defy orders and transmit a reply? What does it mean if the message is nothing more than a calibration signal, or if it is an invitation to a conversation that could change the fate of humanity? Stay with me, because in the next section, the world's reaction takes center stage. The leak you've been waiting for is about to happen, and the consequences will reverberate around the globe. Rumors rarely respect secrets, and in the age of instant communication, they spread faster than light. While Dr. D'Souza's team wrestled with hydrogen pulses and government edicts, whispers of an alien signal began to slither out from behind the firewall. It started innocently, an anonymous post on an obscure forum claiming to have insider knowledge, a screenshot of a waveform purporting to be from an interstellar comet, a cryptic tweet with 6 numbers separated by commas. Within hours, hashtags sprouted. Comet message, alien countdown, 6 numbers. People in chat rooms argued over whether it was a hoax. Conspiracy channels on video platforms promised exclusive footage if you subscribed. A well-known influencer went live from his studio, eyes wide with excitement, promising his 10 million followers the truth. "The government won't tell you this," he whispered, "but we're about to make contact." Comments streamed in from around the world, scrolling so fast they were unreadable. Some viewers typed hearts and rocket emojis, others typed prayers. One skeptic wrote, "It's just a weather balloon like everything else." Another user replied, "Open your mind." And somewhere deep in that swirling digital noise, the truth was hovering, waiting to break free. At first, official channels denied everything. The press offices of national space agencies issued statements that there was no evidence of any extraterrestrial transmissions. They explained that comets could emit radio waves through natural processes and urged people not to spread misinformation. But their dry language couldn't compete with the emotional power of a potential first contact. In the absence of clarity, speculation abounded. A conspiracy theorist with a slick intro sequence claimed to have intercepted the 6-number signal using a homemade dish. He played a series of beeps over a dark background and declared, "This is them. They are calling us." In the comments, some accused him of faking, others demanded governments be transparent. Meanwhile, a professor of astrophysics did an AMA, Ask Me Anything, on social media, patiently explaining the difference between broad absorption features and narrowband signals, but few listened. The algorithm rewarded outrage and wonder more than nuance. People built elaborate stories about who these aliens might be. One thread insisted they were ancient beings returning to check on their experiment. Another said they were AI from a distant galaxy looking for new hardware. A third claimed the signal was a psyop by rival nations to justify increased defense budgets. Behind the scenes, real governments were far more cautious and far more concerned. After Dr. D'Souza's group was barred from responding, diplomats and advisors began drafting contingency plans. They dusted off a document titled Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. First crafted in 1989 and updated in 2010. The principles recommended that any confirmed detection be shared promptly through scientific channels, and that the data be stored in multiple secure locations accessible to international stakeholders. The updated draft circulating in 2025 suggested a crucial addition. No reply should be sent until after a thorough discussion at the United Nations. The rationale was simple and sobering. No single nation should speak for Earth. This shift reflected lessons from decades of geopolitical tension and the rise of social media. It also acknowledged that the world had become far more complex. Coordinating a global response would be messy and slow, but any premature reply could spark unintended consequences. As one advisor told the UN, Secretary General, "It's not just about who presses send. It's about who we become when we decide to answer." Scenes from different capitals underscored the gravity. In Washington, senior officials from NASA, the Pentagon and the Department of State sat in a windowless room, staring at a projection of the hydrogen pulse sequence. A general asked whether the signal posed a threat. A diplomat asked whether it could be harnessed for political gain. A scientist pointed out that the signal had been traveling for years before reaching us. If there was danger, it was already here. In Beijing, members of the Chinese Academy of Sciences and the People's Liberation Army met to discuss whether the signal might be a foreign hoax or an opportunity to unite the country behind a common cause. In Moscow, the space agency Roscosmos reached out to its counterparts, seeking access to raw data. In Brussels, the European Space Agency convened its Science Advisory Board. In Addis Ababa, the African Union considered whether this was a chance to assert a voice in global space policy. And in Geneva, representatives from the International Telecommunication Union debated whether to free up the 420 MHz band to protect the signal from interference, an unprecedented move that would disrupt commercial and military communications. Everywhere, people were asking variations on the same question. If this signal is real, what do we do? Away from conference rooms and control centers, the news hit families and individuals in unpredictable ways. At a small kitchen table in a suburb of Cape Town, a young radio astronomer who had been part of the verification team stared at her phone, watching the trending hashtags. Her name was Tandu, and she had not told her parents what she had been working on. When her mother asked why she looked so pale, she hesitated. Should she burden her family with the weight of knowledge? Her father switched on the television to a local news station where a panel of experts debated whether the government should release more information. The anchor asked, "Would you want your daughter to know if aliens were calling?" Tandu stared at the screen and whispered, "They might already know." In her private message inbox, she found a note from a colleague warning everyone not to open any attachments from unknown senders. There's a phishing attempt going around disguised as the signal. Even at home, the paranoia had reached them. As Tandu scrolled, she saw a message from her younger brother, a teenager with an interest in science fiction. He'd written, "Are we going to die?" She closed her phone and hugged him. "No," she said, "we're just going to learn." Elsewhere, religious leaders took to their pulpits. In Lagos, a charismatic pastor held up a printout of the 6 numbers and declared them the new commandments. He told his congregation that the comet's message was a sign from God, confirming that the end times were near and that only those who donated generously would be saved. The crowd shouted, "Amen," and many reached into their pockets. In a small temple in Varanasi, a Hindu priest lit oil lamps and chanted ancient verses, then whispered that the signal was evidence of the universe's endless cycles. Just as cosmic waves repeat, so do human lives. In Jerusalem, a rabbi explained to his students that if intelligent life existed elsewhere, it was part of God's plan, and our duty was to approach it with humility. In a rural church in the American Midwest, a minister warned that the signal could be a deception by demons seeking to lead humanity astray. Some faithful nodded, others rolled their eyes. On a live stream, an imam in Cairo reminded his followers that the Quran speaks of beings called jinn who live in dimensions beyond our perception. If the jinn were communicating, we should fear God and seek guidance. The diversity of interpretations reflected humanity's own myriad beliefs. For some, the signal was a test of faith. For others, it was proof that their faith had been right all along. Amid the noise, a quieter voice emerged. In a primary school in São Paulo, a teacher asked her class to write a letter to whoever might be listening. One 9-year-old girl with big brown eyes and curly hair wrote, "Dear space people, we don't know who you are, but we are nice. We have water and chocolate. Please be kind to us. Love, Anna." She drew a smiling comet and 2 stick figures holding hands. Her letter went viral when her teacher posted it with her mother's permission. The simplicity of Anna's message touched millions. It was reprinted in newspapers, translated into dozens of languages, and read on evening news broadcasts. People wrote in the comments, "This is the best ambassador Earth could send." Others added, "Where do I sign?" Meanwhile, fan art flourished. Drawings of comets with faces, images of aliens eating chocolate, memes of humanity offering water. Anna's letter reminded everyone that beyond politics and religion, there were children whose future would be shaped by whatever decisions adults made. As one commenter put it, A 9-year-old has captured more humanity in 30 words than most of us do in 30 years. Then, like a bolt of lightning in a dry forest, the leak happened. It wasn't subtle. Screens across the globe lit up with a plain text file posted on a popular file sharing platform. It contained the raw signal data, timestamps, frequency readouts, amplitude measurements, and the 6 numbers repeated over dozens of lines. Alongside, it was a manifesto written by someone calling themselves Yi Park. Whether it was truly Yi or someone posing as him, the document was passionate and urgent. "This belongs to humanity," it began. "Governments have no right to hide it." The writer recounted how the data had been locked behind a restricted server, how he had been silenced for trying to share it, and how the people deserved to know. The manifesto ended with a call to action. Spread this everywhere. Verify it, decode it, decide together. Within minutes, the file had been downloaded hundreds of thousands of times. Mirrors appeared on other sites. Memes popped up featuring a masked hacker face with the caption, "Signal Liberation Front." News outlets scrambled. Some hesitated to report on leaked data. Others splashed it across their front pages. A live map showed pins popping up as more people downloaded the file. The cat was not just out of the bag. It had cloned itself and multiplied. A cacophony of voices erupted. Some hailed the leaker as a hero. Others condemned him as reckless. Governments issued stern warnings about sharing classified data. Social media platforms struggled to decide whether to remove the links. Some did, many didn't. The more authorities tried to control the leak, the more it spread. A prominent talk show host invited a cybersecurity expert to discuss the leak. "Can we be sure this data is authentic?" she asked. The expert replied, "It looks real. The timestamps, the noise patterns, if it's a hoax, it's the best I've ever seen. And besides, thousands of amateur astronomers can now point their dishes and confirm it themselves." That was the next domino to fall. Amateur radio enthusiasts worldwide pointed their makeshift antennas at the comet and listened. Forums filled with reports. "I'm in Osaka and I hear the pulses." Confirmed from rural Saskatchewan. "I'm in Nairobi, there's interference from the city, but after filtering, I see it too." The pattern was unmistakable. Within 24 hours, independent confirmations poured in from all continents. The leak had done what no government could. It democratized the signal. To convey the enormity of the leak, the documentary pauses narration and presents a montage. A split screen shows news anchors in Lagos, Tokyo, Paris, and Buenos Aires reading the numbers aloud in their native languages. The camera cuts to a protest in Seoul where people hold signs saying, "Don't hide the signal," and "We are one Earth." In Moscow, a group of older women in headscarves stand in a marketplace, arguing about what the numbers mean. In Johannesburg, a taxi driver shakes his head at the radio and mutters, "They always keep secrets." In a dark room in Buenos Aires, a teenage gamer streams to his followers, his face lit by the glow of his screen, chanting 1420405751768 like an incantation. In a remote village in the Himalayas, villagers who have never used the internet gather around a battery-powered television brought by a traveling salesman and hear the story translated by a local teacher. The montage ends with a shot of the Earth from space at night, lights glittering like static. The comets trail a faint line through the darkness. Then, for 5 seconds, there is silence, no music, no narration, allowing the weight of a world listening to settle in. Silence gives way to debate. Scientists who had been shut out of the restricted server now had access to data. In Leiden, astrophysicists at the University of Leiden downloaded the file, applied their own algorithms, and confirmed the narrowband nature of the signal. They published a preprint. Peer review would take too long, stating that the data was consistent with an extraterrestrial transmission. In Canberra, a skeptical researcher argued in a blog post that the pattern could be a coincidence produced by rare atmospheric refraction and random cosmic noise. His post went viral among skeptics, but when independent confirmations kept rolling in, he posted an update acknowledging, "We must consider the extraordinary." In Tokyo, linguists plotted the pulses and found that the intervals between them followed a pattern similar to Japanese poetic meter, though they cautioned against anthropocentrism. In Berlin, sociologists held a round table on how marginalized communities might interpret the signal. In Nairobi, a panel on local radio asked whether Africa should insist on a seat at the table if Earth decided to reply. The democratization of data democratized discourse. For the first time since the discovery, the conversation was global and uncontrolled. Governments scrambled to regain footing. The U.S. President addressed the nation in a primetime speech. "My fellow citizens," she began, "we are living through a moment of unprecedented wonder and uncertainty. Scientists around the world have detected an unusual signal associated with an interstellar object passing through our solar system. We are working closely with our international partners to verify its nature and to determine the best course of action. I want to assure you that your government is committed to transparency and to your safety. Please do not spread unverified information, and please trust that we will share more as soon as we can." In the UK, the Prime Minister issued a similar statement but was interrupted by protesters outside the Parliament chanting, "Tell the truth." In India, the Prime Minister tweeted a poem about the cosmos and the unity of humankind, which was both praised and mocked. In Brazil, the president dismissed the signal as alien nonsense and said the country had more pressing issues. In Canada, the science minister held a town hall where she listened to citizens' concerns. In Russia, the government remained largely silent, fueling rumors. Silence itself became a message interpreted in many ways. Within Dr. D'Souza's group, the leak ignited panic and relief. Some scientists were angry that their work had been stolen and published without context. Others were grateful that the burden of secrecy was lifted. Priya shook with a mix of emotions. "Now the whole world knows," she said, "but do they know enough to understand?" Dr. Liu was worried that the raw data might be misinterpreted. "We could set off a stampede of speculation," he warned. Dr. D'Souza felt a weight lift from her shoulders. "At least we're not alone in this anymore," she said, yet the undersecretary who had banned them from transmitting stormed in. "Do you know what you've done?" he shouted, assuming someone on the team had leaked it. "This could cause panic, war, collapse." Dr. D'Souza met his gaze. "Or it could cause collaboration," she replied. Behind her, a screen showed the number of downloads climbing every second. The Pandora's box was open. The debate turned to damage control. Should they release an official interpretation to prevent misreading, or stay silent to avoid further fueling the fire? What about Yi Park's manifesto? Was he alive? Was it really him? Did he act alone? In a grand hall in New York, the United Nations General Assembly convened an emergency session. Delegates from 193 countries took their seats. The Secretary General spoke solemnly. "We face a defining moment," he said. "A signal that may originate from beyond our planet has been detected, and it has now been shared with all of humanity. We must decide together how to proceed. This is not a question for one nation, one religion, or one technology company. This is a question for humanity." He proposed forming an international committee to evaluate the signal and to draft a coordinated response if one were deemed appropriate. The UN chamber buzzed with whispers. Some delegates argued that this was not the UN's mandate. Others said there was no body better suited. A delegate from a small island nation stood up and said, "We do not have radio telescopes, but we have a stake in this. We have children who dream of the stars. Please do not make decisions without us." Applause broke out. Outside the hall, hundreds of activists held signs. "Earth speaks as one. No messages without us. We are not alone. Don't leave us alone." The debate was messy, passionate, and necessary. On the streets of London, a demonstration formed spontaneously. Thousands gathered in Trafalgar Square, some wearing silver foil hats in jest, others carrying serious placards. A woman in her 60s held a sign reading, "Aliens, welcome. Humans, please behave." A group of teenagers danced to a DJ playing a remix of the Six Numbers set to a techno beat. A man shouted through a megaphone, "We demand transparency." Spelled hello. Most professional astronomers dismissed it as pattern-seeking, but the story trended nonetheless. The democratization of data led to an explosion of creativity, pseudoscience, breakthroughs, and dead ends. It was messy, but it was also a display of collective curiosity rarely seen. Not everyone welcomed the signal. Panic took root in some corners. A doomsday prepper community in Montana posted a video telling followers to stock up on supplies because an alien invasion was imminent. Gun stores in parts of the U.S. reported increased sales. In Russia, a surge of people withdrew cash, fearing economic collapse if aliens arrived. In Japan, a myth about the comet bringing bad luck circulated, causing some to cancel weddings scheduled for days when the comet was most visible. Stock markets dipped, then rebounded when analysts pointed out that no immediate threat was apparent. In Lagos, police arrested 3 men who claimed to be selling alien protection amulets. In Manila, a text message scam offered to reserve your seat on the evacuation spaceship for a fee. The signal became fodder for every fear, every scam, every hope. Governments tried to calm nerves. Mental health hotlines reported an increase in calls from people experiencing anxiety about the cosmos. Some schools added units on SETI to their curriculum to educate students and dispel myths. Others banned talk of the signal to avoid distraction. The reaction was as varied as humanity itself. Back at the University of Cape Town, Tandio's phone buzzed with messages. Some friends congratulated her on being part of history. Others begged for insider information. One message came from a number she didn't recognize. It read, "You are being watched, be careful." Her hands shook as she deleted it. On an encrypted chat, she and Priya and a few trusted colleagues discussed what to do next. They had not leaked the data, but they felt responsible for its interpretation. They considered releasing a simplified explanation of the hydrogen line and the prime numbers in the style of Anna's letter, so that the public could understand without misinterpretation. Priya worried about backlash. What if we get something wrong and mislead billions? She asked. Dr. D'Souza joined the chat. Better to try and clarify than let misinformation flourish, she said. The group drafted a statement. It explained that the signal was real, that it consisted of 6 pulses corresponding to prime numbers and a frequency universally associated with hydrogen, and that scientists were working hard to decode the rest. They posted it through official channels, and it was shared widely. Some thanked them. Others accused them of lying. The information war was on. The leak also sparked a philosophical debate about ownership of knowledge. A columnist in The Guardian wrote that the leak was an act of civil disobedience akin to the Pentagon Papers. A commentator on a major U.S. news network called it treason. An opinion piece in the Times of India argued that knowledge of extraterrestrial life, if confirmed, belonged to no government or corporation, but to humanity, and that secrecy only bred distrust. A writer on a tech blog countered that uncontrolled leaks could lead to panic, and that some information should be managed responsibly. A philosopher at the University of Melbourne wrote an essay questioning whether humanity had the moral right to speak on behalf of Earth at all. "We are a fractured species with competing interests," she wrote. "Perhaps silence is the only honest reply." The essay sparked thousands of comments. Some agreed, others mocked the idea of humility in the face of potential aliens. Meanwhile, a group of indigenous leaders released a joint statement reminding the world that not all human cultures have a history of colonial outreach. "We know what happens when newcomers arrive unannounced," they wrote. "Consider this before sending messages into the void." The voices multiplied, each adding texture to the global chorus. As days passed, the intensity fluctuated. Some people grew bored and moved on to other news. Others became more obsessed. A popular TV drama hastily incorporated an alien signal subplot. A fashion brand released a limited edition hoodie with the 6 numbers in neon print, and it sold out instantly. A brewery in Belgium announced a new First Contact ale. Investors asked if space stocks were a good buy. In academia, proposals for grants to study the signal piled up. In a small town in Italy, local musicians composed a symphony based on the pulse sequence and performed it in the town square, drawing tears from listeners who said they could feel the cosmos. Humanity's reaction morphed the signal into a cultural phenomenon. Like any cultural phenomenon, it was commodified, critiqued, celebrated, and lampooned. The comet continued its silent journey, indifferent to the fuss. Even as the world reacted, some looked ahead. Dr. Liu, despite feeling sidelined by the leak, could not stop thinking about the hydrogen line. He scribbled equations on napkins at his kitchen table, trying to predict what might follow the 6 numbers. He hypothesized that the next part of the message might involve multiples of the hydrogen wavelength or might shift to another fundamental constant, like the ratio of hydrogen to helium in the universe. Priya pondered how to design a message back that would be both simple and expressive. She thought of the mathematical concept of a circle, universal, infinite, closed. Could they send the number pi encoded in pulses? Would that be understandable? Meanwhile, Tandya wondered whether 3IATLAS was a messenger or just a mailbox. Was something waiting for a reply? Did they have a moral obligation to answer? She recalled the words of her grandmother. When someone knocks, you open the door, but you don't invite them to stay until you know who they are. The scientists wrestled with these questions even as the world around them seemed to be spinning out of control. In the final scene of this section, the camera pans across different time zones. In New York, it is night, and a child looks up at the sky, trying to spot the comet. Her father points, unsure if he is looking at the right speck. In Tokyo, it is morning, and commuters glance at their phone screens, seeing yet another update about the signal. In Nairobi, midday, schoolchildren laugh as they attempt to clap out the 6-pulse rhythm. In Buenos Aires, evening, lovers sit by the river, whispering about whether aliens might be watching them. In rural Mongolia, a herder who has heard about the signal on a battery-powered radio gazes at the sky and says, "We have always known we are not alone." The narrator's voice returns, softer. A message from the stars has escaped into the hands of billions. How we interpret it, how we act on it, and how it changes us are questions for all of us. The comet will soon swing around the sun and head back to interstellar space. The pulse sequence will continue, indifferent to our chaos. But on this small planet, 8 billion minds are listening, arguing, dreaming. In the next section, we will explore how decoding efforts intensify and how the debate over messaging extraterrestrial intelligence reaches a boiling point. Stay with me, because the next revelation could redefine what it means to be human. The leak changed everything. Once the data was in the hands of the masses, it was no longer just the domain of governments and select scientists. Around the world, independent researchers fired up laptops, pointed antennas, and gathered in makeshift labs. They shared code on open-source platforms, started collaborative spreadsheets, and live-streamed decoding attempts. A new wave of curiosity swept across universities, hacker spaces, living rooms, and backyards. The 6 numbers that had once been whispered in secret now lit up screens from Lagos to Los Angeles. In Cambridge, a mathematician known for cracking encryption algorithms wrote on her blog, "If there is meaning in this pattern, it will reveal itself." She invited volunteers to join her in an online forum. In Nairobi, an astrophysics grad student posted a thread titled, "Let's decode this together," attracting thousands of comments in hours. On a video platform, a popular science communicator launched a series called Decode the Universe, breaking down what spectral lines were and why hydrogen mattered. People who had never thought about radio astronomy found themselves captivated by the idea that the universe might be speaking in mathematics. As the global collaboration unfolded, patterns began to emerge beyond the initial prime numbers. A group of researchers at the University of São Paulo plotted the pulses against known atomic transition frequencies. One data point caught their eye. When they graphed the spacing between pulse groups, they noticed a ratio of approximately 1.78:1. This number was familiar. It was the ratio between the 21-centimeter hydrogen line, 1,420 megahertz, and a 12-centimeter spectral line associated with carbon atoms, around 2,458 megahertz. Hydrogen and carbon are the 2 most abundant elements in organic molecules. The researchers cross-checked other data sets and found the same ratio repeated throughout the signal's substructure. They published a preprint, "Evidence for Hydrogen-Carbon Ratio in the 3IATLAS Signal." The paper suggested that the sender might be highlighting both hydrogen and carbon, hinting at water, hydrogen, and oxygen, and the building blocks of life, carbon chains. The idea rippled through the decoding community. A biochemist in Seattle wrote, "If this is intentional, they're saying, we know hydrogen, we know carbon, we know what life is made of." On forums, people debated whether carbon's 12-centimeter line was widely known enough to be used in a cosmic handshake. Others pointed out that carbon's significance would be obvious to any species capable of chemistry. The hypothesis held, the signal's authors might be establishing a shared scientific vocabulary. The hydrogen-carbon ratio sparked a flurry of speculation. What if the numbers were not just primes, but a sequence of steps? Hydrogen first, carbon second, like an introduction and a handshake. In a Slack channel devoted to the signal, a mathematician from Toronto and a biologist from Mumbai collaborated on a hypothesis. They suggested that the pulses might be forming a fractal pattern that mirrored molecular structures. Consider benzene, the biologist wrote, sketching a hexagon. Carbon atoms arranged in a ring with hydrogen atoms around them. 6 hydrogens, 6 carbons, 6 pulses, the mathematician responded, and the ratio between the spectral lines corresponds to the energy levels in benzene rings. Coincidence? They shared their conjecture publicly, and within hours, other scientists chimed in. Some dismissed it as overreach. Others noted that benzene is a fundamental molecule in organic chemistry. Whether or not the theory held, it illustrated how the signal was inspiring cross-disciplinary thinking. People who normally worked in isolation were now combining their expertise in novel ways. The hydrogen-carbon ratio became a bridge between fields, just as the signal itself was a potential bridge between species. Meanwhile, another thread emerged. A team of physicists in Berlin examined the numbers themselves, stripped of their timing. They factored each number into primes and looked for relationships to known constants. Surprisingly, they found that when you multiplied the 6 numbers together, the product could be expressed as a ratio of the fine structure constant, approximately 1/137, and Avogadro's number 6, 22 times 1023. It was a tenuous link, but tantalizing. The fine structure constant is fundamental to electromagnetism, and Avogadro's number relates to the amount of substance. If this is deliberate, the lead researcher said in a recorded interview, it means the sender is compressing a lot of physics into a simple sequence. They're saying, we understand electromagnetism. We understand moles of matter. We understand the same constants you do. This interpretation, though less popular than the hydrogen-carbon ratio, underscored a growing consensus that the 6 numbers were a gateway into a larger scientific lexicon. To send such a message, the authors would need to assume the recipients understood prime numbers, spectral lines, and fundamental constants. It was as if they were building a cosmic dictionary, beginning with the most universal entries. As decoding efforts branched in multiple directions, the missing engineer story resurfaced in an unexpected way. 2 weeks after the leak, a middle-aged woman in Busan, South Korea, received an email from an address she didn't recognize. The subject line contained only 6 numbers. The email body was blank except for the same 6 numbers repeated 3 times. The woman's name was Yumi Park. She was Yi Park's sister. She hadn't heard from her brother since he disappeared. She had seen his name trending on social media and had been bombarded by reporters, but she had refused to speak publicly. Now, staring at the cryptic email, she felt a mix of dread and hope. Was it from Yi? Was it a warning? A clue? Yumi forwarded the email to a friend who knew about the signal and asked what to do. The friend told her to take a screenshot and share it with someone trustworthy. Yumi considered going to the police but feared they would confiscate her phone. Instead, she called a journalist who had been covering the story responsibly. In a quiet cafe, she showed him the email. He took photos and asked, "Do you think Yi sent this?" Yumi didn't know. The journalist reported the story without revealing her identity, and speculation exploded. If the email was real, it suggested that someone inside the project, perhaps Yi, was bypassing official channels to reach his family. It also raised the possibility that others close to the researchers might be receiving similar messages. The subplot thickened. The signal was no longer just cosmic, it was personal. Within Dr. D'Souza's team, the email caused a stir. Priya, who had grown close to Yi during the early days of decoding, felt a pang. "If Yi sent this," she said, "he's alive and trying to communicate. But what is he trying to say? Just the numbers? Or is there something encoded in the repetition?" Dr. Liu suggested that the triple repetition could imply emphasis or could be a signal to look at the third derivative in the data. Tandia wondered if the email itself was bait, a way for someone to trace who was in contact with whom. The team forwarded the email to cybersecurity experts, who determined it had been sent through an anonymizing service. They could not trace its origin. The message reintroduced uncertainty and fear. Was the missing engineer watching them? Was he being held by someone? Did he want them to leak more? Did he have access to more data? The specter of an insider leak undermined the authority of the official project and highlighted the human drama behind the science. As the decoding progressed, a conceptual bombshell dropped. A team from the University of Cambridge, working with colleagues in Tokyo and Cape Town, built a simulation to model the travel time of the signal. They considered the speed of light, the comet's trajectory, and the likely distance of potential origin points within our galaxy. They discovered that if the message had been sent from a star system 100 light-years away, it would have had to be transmitted a century before 3IATLAS was even discovered. If it had originated 10 light-years away, it would have left its source a millennium ago. And yet, the pulses arrived precisely as the comet passed through our inner solar system, intersecting the orbits of inner planets. The timing implied either astonishing coincidence or exquisite planning. One professor put it bluntly in a televised interview. For the signal to arrive at this exact moment, the senders would need to know the orbit of 3IATLAS, the motion of our solar system, and perhaps even predict when we would have the technology to detect it. This suggests a level of astrophysical computation far beyond our current capabilities. Either that, or the universe is playing tricks. The idea that someone, or something, had calculated cosmic trajectories hundreds or thousands of years in advance sent shivers through the scientific community. It elevated the message from a simple handshake to a feat of cosmic choreography. To help the public grasp this scale, the documentary cuts to a hand-drawn map of the Milky Way. A narrator points out our position about 27 light-years from the galactic center. A tiny dot marks the Sun. Another dot marks an approximate sphere 100 light-years in radius, representing the zone from which signals could reach us within the last century. Concentric circles illustrate 10, 50, and 10 light-years. The narrator explains that 3IATLAS's origin is unknown, but its path suggests it comes from well above the galactic plane. A dotted line traces the comet's trajectory, arcing through our solar system like a spear. Overlaying the trajectory is a translucent cone representing the possible origin directions of the signal. The map zooms in on a cluster of stars in the cone. Each star could, in theory, have sent the signal. The narrator then overlays the timeline. If the signal came from 10 light-years away, the senders would have to aim it to intersect with our solar system at precisely the right time and angle, accounting for the comet's path. The visual underscores the complexity. Viewers can see that sending a message on such a trajectory would require knowledge of celestial mechanics across millennia. The pattern interrupt lets the audience absorb the enormity of the puzzle before plunging back into the narrative. After the map, the film shifts to a quieter montage of people stargazing. There is no narration, only ambient sounds. The chirping of crickets, the rustle of leaves, the hum of distant traffic. A family in rural Kenya lies on blankets, pointing out constellations to their children. A couple in Madrid leans out a balcony, sharing a pair of binoculars. A farmer in Iowa takes a break from his harvest to sit on his tractor and stare at the night sky. A prisoner in a crowded cell in Bangkok gazes at the sky through a barred window, whispering a prayer. An elderly woman in Tokyo stands on her rooftop, holding a photo of her deceased husband, tears in her eyes as she whispers to the stars, "Are you out there?" A teenage boy in Brazil sits on the hood of his car with friends, laughing as they invent stories about alien life. These images remind viewers that the mystery of the cosmos doesn't just belong to scientists or governments. It belongs to everyone. In the quiet, we sense the shared human experience of wonder and smallness. Back in the data labs, the hydrogen-carbon idea gained traction. Biologists joined the conversation, noting that water requires hydrogen and oxygen, while organic molecules require carbon. They suggested that if the message was indeed highlighting hydrogen and carbon, it could be a nod to water and life. A microbiologist from the University of Cape Town pointed out that many simple organisms thrive in environments rich in hydrogen and carbon compounds. If someone wants to say, "We know life as you know it," this is how you start, she said. On a conference call, a chemist suggested that the 6 numbers might correspond to atomic numbers, 1 for hydrogen, 6 for carbon. But there were 6 numbers, not 2. Another scientist suggested grouping them, 1 and 4, hydrogen isotope helium, 2 and 0, 4 and 0, carbon again, 5 and 7, iron, 5 and 1, vanadium, 7 and 6, osmium. The speculations spun into a kaleidoscope of possibilities. Some were plausible, others were wild. But the process itself was valuable. The signal was forcing scientists to think creatively, to break out of disciplinary silos, to collaborate across continents. As the scientific community dived deeper, the public narrative continued to evolve. A documentary filmmaker in Paris released a short film that juxtaposed the 6 numbers with images of DNA, nebulae, and ancient cave paintings. It went viral. A musician in Nigeria composed a song using the pulse timings as a rhythm and lyrics about unity and curiosity. It topped streaming charts. A comic artist in Seoul published a web series about a group of kids who decode an alien message. It became a hit. On late-night television in the US, comedians joked about aliens sending a sext after misreading Earth's radio signals. The signal permeated culture. Teachers incorporated lessons about prime numbers, hydrogen, and carbon into their curricula. Churches, mosques, and temples held discussions. The signal was no longer just a piece of data. It was a mirror reflecting humanity's hopes, fears, and creativity. In the midst of this cultural explosion, Yumi Park received another message. This time, it arrived in the mail, a postcard with no return address. On one side was a photograph of a comet streaking across a dark sky. On the other side were the same 6 numbers, handwritten in neat block letters. Below the numbers were 6 letters in Hangul, the Korean alphabet, spelling out, "Ka Sateng He Inus?" I love you. Yumi's hands trembled. Was this Yi's way of telling her he was alive, or was it someone playing a cruel joke? She brought the postcard to the journalist she trusted. Together, they contacted a forensic analyst, who concluded that the postcard had been mailed from within South Korea and that the handwriting resembled Yi's, though it could not be confirmed. The story broke online. People swooned at the idea of a missing engineer sending love through code. Others accused Yumi of fabricating the story for attention. The subplot underscored that behind the cosmic drama, there were real people experiencing loss, hope, and fear. The journalist interviewed Yumi, who spoke tearfully about her brother. Yi loved puzzles. When we were kids, he would leave clues around the house. He used numbers and codes. I want to believe he's alive, but I don't know. If he's sending messages, I hope he knows we love him too. As Section 5 approached its emotional crescendo, the conceptual weight of the timing debate hung heavy. Dr. D'Souza sat in her office, staring at the equations on her whiteboard. Priya paced, muttering to herself about cosmic choreography. Dr. Liu scribbled on a pad, his eyes bloodshot. If someone timed this, he said, how? They'd need to know the mass of every planet, the gravitational influence of every passing star, the exact moment we develop radio astronomy. The path of a comet ejected from the Oort cloud, it boggles the mind. Priya responded, maybe they can see futures we can't, or maybe they've been watching us for a while. Dr. D'Souza remained silent. She thought about the map of the Milky Way, the possible origin points, the centuries the signal might have traveled. She thought about the 9-year-old girl's letter, the protests, the global vote that seemed inevitable. She felt the weight of the moment. If the message was real, it was more than a handshake. It was a statement of cosmic power and patience. It suggested we were not just being acknowledged, we were being tested. The section begins to wind down with a summary of the decoding progress so far. The narrator recaps. Scientists have identified that the pulse spacing corresponds to the hydrogen line frequency, hinting at a universal unit. Independent researchers have proposed that the ratios in the signal align with carbon's spectral lines, suggesting the senders are pointing to the basic building blocks of life. Others have found intriguing links to fundamental constants, indicating that the message might be establishing a mathematical and scientific vocabulary. The missing engineer's family has received mysterious messages, raising questions about insider knowledge and personal stakes. And perhaps most astonishingly, the timing of the signal's arrival suggests a level of cosmic foresight that defies our current understanding. These discoveries lead to new questions. Is there more information hidden in the noise? Will the senders reveal their identity, their location, their intentions? What kind of beings can plan across millennia? And, crucially, how should humanity respond? As we prepare to transition into Section 6, the ethical debates simmer. In the streets, people are no longer just chanting for transparency, they are chanting about the right to reply. Answer them, some shout. Stay silent, others respond. Philosophers write op-eds about the consequences of revealing our existence to potentially advanced beings. Politicians worry about national security. Scientists worry about miscommunication. And Priya, Dr. D'Souza and Dr. Liu worry about missing their chance to send a message while the comet is still within range. In a televised debate, a famous author argues, silence is a statement too. If we say nothing, we might be perceived as unintelligent or disinterested. Is that the impression we want to give? A military analyst counters, if we reply, we might attract attention from predators. Maybe this is a trap. A child in the audience asks, what if they just want to say hello? The moderator smiles and says, and that is the question for all of us. We close Section 5 with a final image. The camera focuses on the comet, now past its closest approach to the sun, beginning its outward journey. The tail glows against the blackness. The pulsing beacon continues, sending 6 numbers over and over, carrying ratios of hydrogen and carbon, perhaps more. Earth rotates below, enveloped in clouds, oceans, and city lights. The narrator speaks softly. We have decoded the first layer of the message. We know it speaks of hydrogen and carbon, of physics and life. We know it arrived at this moment through astonishing coincidence or design. We know someone out there, or something, has done what we can barely conceive. But many mysteries remain. What else lies hidden in the noise? Who sent the cryptic emails? What motives drive the senders? And when the world is asked whether to reply, what will it say? The narrator pauses. Stay with me. In the next section, the debate over responding ignites, the missing engineer's manifesto surfaces, and the fate of humanity's voice hangs in the balance. The discovery that the 6 pulses from 3IATLAS point to hydrogen and carbon elements fundamental to life sent shockwaves through every discipline. But decoding was only half the journey. The next question loomed larger. Should we respond? Humanity suddenly found itself in the awkward position of a host who has received a greeting from an unknown guest at the door. Do you shout back a welcome, whisper through the keyhole, pretend you aren't home? The debate was not theoretical. It carried potential existential consequences. In the weeks following the signal's public release and the subsequent decoding breakthroughs, the conversation shifted from what the message meant to what our answer should be. We have read their hello, one commentator put it. Now what do we say? Government agencies began meeting around the clock. In Washington, an emergency session gathered scientists from NASA and the national academies alongside representatives from the Department of Defense, State Department, and a panel of ethicists. The agenda was to discuss possible responses in light of the International Academy of Astronautics, updated post-detection protocols, which recommended that no reply be sent until the United Nations had discussed the implications. The protocols also advised that all data be preserved in at least 2 secure locations and made accessible to international stakeholders for verification. A NASA scientist, leaning forward, urged caution. We should hold off on any reply until we have universal consensus, she said. A representative from the Pentagon raised the specter of potential threats. We cannot rule out the possibility that revealing ourselves might attract attention from malevolent forces, he warned. A representative from the State Department asked, what if silence is interpreted as ignorance or disinterest? Could that harm us in unknown ways? An ethicist from a university countered, refusing to reply could be seen as arrogance. Assuming our safety is more important than making a connection. The meeting stretched late into the night as voices clashed and tired eyes scanned documents. No consensus emerged. Across the Atlantic in London, the Royal Society hosted a forum where scientists, philosophers, and military advisors debated on stage before a live audience. Dr. Maya D'Souza, flown in as an expert witness, found herself facing pointed questions. "Isn't it reckless to reply when we don't even know what the message is?" asked a retired admiral. "Isn't it reckless not to reply if the message is friendly?" she retorted. A philosopher pointed out that no society had ever made contact with an entirely unknown civilization. Our precedents on Earth were colonial encounters, where the more technologically advanced society dominated the other. "We must consider who we are in this dynamic," she said. "Are we Columbus or are we the Taino?" A linguist suggested that silence speaks volumes. In human communication, not answering can end dialogues. A former astronaut in the audience stood up. "When I orbited Earth," he said, "I felt how small we are. If someone is calling, I want to answer. That is who we are, explorers." The audience applauded. A live poll flashed above the stage. 63% of viewers wanted to reply, 27% wanted to wait, 10% were undecided. Meanwhile, the military and intelligence community convened their own workshops. In a secure facility, analysts played hypothetical scenarios on screens. One simulation imagined that replying might attract a swarm of von Neumann probes, self-replicating machines that could strip planets of resources. Another scenario posited that remaining silent might be interpreted as fear, inviting exploitation. A naval intelligence officer invoked the Fermi paradox and suggested that perhaps civilizations that broadcast their presence tend not to survive. "Silence might be the wise course," he said. A young analyst countered, "But what if everyone is silent for that reason? Then we'd all be alone forever." Over coffee, a physicist whispered to a colleague that secrecy itself could be interpreted as aggression. "If we're the only silent ones, it might look like we're hiding something." The discussions circled back to the central dilemma. Ignorance of intention breeds fear, but fear alone is not a strategy. The meetings ended with no decisions, only thicker folders of briefing notes and an agreement to keep talking. Scientists outside government circles continued their advocacy for communication. A group called Scientists for Cosmic Dialogue wrote an open letter signed by 50 researchers worldwide. "We have been listening to the universe for decades," the letter said. "Now that a potential message has been received, our responsibility is to respond thoughtfully and transparently." They proposed a reply consisting of the same 6 numbers, followed by representations of the hydrogen and carbon spectral lines, and a simple mathematical constant like pi. "We propose this as a universal handshake," they wrote. "It is neither threatening nor revealing of our location beyond what is already known, as the original message was aimed directly at us." They also called for public input. The letter was published in major newspapers and widely shared online. Within hours, critics responded. A columnist in a national paper wrote, "These scientists are playing with fire. Curiosity is a luxury when the stakes are extinction." Another writer argued that transparency was essential. Secrets breed conspiracy theories and mistrust. On talk shows, guests debated whether scientists had any more right than farmers or fishermen to decide what to say on behalf of Earth. Philosophers and ethicists became unexpected celebrities. Panels featuring them drew large online audiences. One ethicist argued that any reply should be preceded by global consent because it could alter humanity's trajectory. "Consent must be informed and collective," she said. "To speak without consent would be a violation of our collective autonomy." A philosopher specializing in interspecies communication raised the issue of misinterpretation. "We might think we're saying hello, but we could be broadcasting insults in an alien context," he cautioned. Another ethicist invoked the concept of cosmic humility. "We should be humble enough to admit that silence might be safer," he said. Yet another responded, "But humility doesn't preclude curiosity. They can coexist." Many viewers expressed frustration. "These academics live in abstractions," tweeted one user. "I just want to know if someone is out there." A high school student wrote an op-ed in her local paper arguing that the debate itself was a sign of our maturity. "We're not rushing," she said. "We're thinking that's progress." The missing engineer's story took a dramatic turn when a manifesto surfaced on a social media platform. The account that posted it used the handle @CosmicWhistleBlower. The manifesto was titled "Answer the Universe." It began by recounting the writer's experience working on the 3IATLAS project. The tone suggested it was indeed Yi Park, but the identity remained unverified. "I have seen wonders," it read. "I have seen our governments hesitate and hide. I have seen fear used as a weapon to silence curiosity. I cannot be silent." The manifesto argued that the signal was meant for everyone and that responding was a right, not a privilege. It criticized secrecy and called on citizens to protest until their leaders committed to reply. The manifesto ended with a poetic plea: "The universe is speaking to us. Are we so afraid of our own voice?" Within minutes, the manifesto was shared millions of times. Hashtags like Answer the Universe and Speak for Earth trended worldwide. Some praised Yi as a hero, others accused him of recklessness. In cities around the globe, people began organizing rallies. The protests were as diverse as humanity itself. In Buenos Aires, thousands marched down Avenida 9 de Julio, waving banners that said, "Send the message," and playing drums to the rhythm of the 6 pulses. In Lagos, a crowd gathered outside the National Assembly, chanting, "Tell them who we are," and demanding a response. In Seoul, students held up photos of Yi Park and signs reading, "Our voices matter." In Berlin, protesters carried a giant helium balloon shaped like a speech bubble that read, "We can't be silent." Not all demonstrations advocated replying. In Athens, a group called Silence for Safety marched with signs that said, "Caution is courage." In Cairo, demonstrators argued that the world should fix its problems on Earth before talking to the stars. In Mumbai, a group led by a monk chanted silently, making the point that silence can be as powerful as speech. Police in some cities blocked major roads. In others, they marched with protesters, treating the demonstrations like festivals. News helicopters captured aerial shots of swirling crowds that looked like human galaxies. Street interviews became a staple of nightly news and social media feeds. A reporter in a rural Kenyan market asked a farmer, "Do you think we should reply?" The farmer, holding a sack of maize, shrugged. "If someone calls your name in the dark, do you answer?" he asked. "Sometimes I do. Sometimes I stay quiet." A teenager in Tokyo wearing a t-shirt with the 6 numbers printed on it grinned. "Absolutely," he said. "We owe it to the universe to say hi. Maybe they have cool technology." An elderly woman in Moscow shook her head. "No," she murmured. "When I was young, I answered strangers at the door and bad things happened." A fisherman in a coastal village in the Philippines leaned on his boat. "We rely on the sea," he said. "We trust storms to tell us when to sail. Maybe this is like a storm. Listen first." A professor of anthropology in Lima stood outside her university and said, "We need to agree on what voice we use. What language? What symbols? We can't just shout in English and assume it's universal." These snapshots of opinion painted a complex picture. Humanity was not unified, yet nearly everyone felt invested. The mounting public pressure forced governments to make concessions. Reluctantly, officials announced that a working group would be formed to draft a possible reply. This group would include scientists, linguists, philosophers, diplomats, and representatives from various cultural backgrounds. However, any final decision on whether to send the reply would require global consensus, likely through the United Nations. The group's task: design a message that was scientifically accurate, ethically sound, and devoid of sensitive information like our precise location or military capabilities. They convened in Geneva under tight security. Dr. D'Souza, Priya, and Dr. Liu were invited. So were representatives from the African Union, the European Union, ASEAN, and the Organization of American States. A linguist from Ethiopia, a mathematician from China, and a philosopher from Canada joined the table. A panel of artists and musicians was also invited, recognizing that art communicates beyond words. A diplomat joked, "If aliens understand Beethoven better than binary, we should be prepared." The meeting began with the reading of the post-detection protocols, then moved into a brainstorming session. The participants discussed whether the reply should mirror the hydrogen-carbon theme, include other universal constants like the speed of light, or incorporate pictorial information like a map of pulsars that Carl Sagan once included in messages launched aboard the Pioneer probes. They debated whether to mention Earth's location. Dr. Liu argued that the sender already knew our location, otherwise, the message wouldn't have found us. Priya suggested including a representation of DNA. A philosopher cautioned that different civilizations might not have DNA. An artist drew spirals and circles. The group realized that designing a message to unknown beings is both exhilarating and maddening. While the working group deliberated, the question of who should decide remained. The United Nations took center stage. The Secretary General proposed a global poll, open to anyone with internet access or via physical voting centers in regions with limited connectivity. The poll would pose a simple question: should humanity send a reply to the 3IATLAS signal? The UN promised to translate the question into every language and to set up accessible voting booths. They partnered with tech companies to ensure security and prevent bots from skewing results. Skeptics doubted whether a global poll would be fair or representative. What about people without internet? What about authoritarian regimes that might prevent citizens from voting? The UN acknowledged the imperfections, but argued that some democratic mechanism was better than none. They announced the poll would open on a given date and remain open for 72 hours. The world held its breath. Commentators compared it to historic referendums. This could be the most consequential vote in human history, a historian said. And unlike any election, everyone is voting on a single question, not choosing among candidates. Billboards, bus ads, and social media posts encouraged participation. Your voice matters to the universe. Vote. As the poll approached, the atmosphere was electric. Debates raged at dinner tables, in classrooms, and at workplaces. In a small town in Illinois, a family gathered around their kitchen table after dinner. The father, an engineer, argued in favor of replying. "We're explorers," he said. "Imagine if the Wright brothers had decided not to fly." The mother, a nurse, worried. "What if we're risking our children's future?" she asked. Their teenage daughter rolled her eyes. "You're both being dramatic," she said. "They probably don't even care about us." The family laughed, then fell into thoughtful silence. In Lagos, a journalist interviewed a taxi driver. "Will you vote?" she asked. "Yes," he said. "Why?" she pressed. He smiled. "Because my grandson asked me to." He said, "Grandpa, the aliens are calling. We have to answer or they'll think we're rude." In New Delhi, two grandmothers argued over the market stalls. "We should reply," said one. "We are curious beings." The other shook her head. "We should pray," she said. "Let God answer." They both laughed. The poll became the world's dinner conversation. On the day the poll opened, the internet slowed. Millions logged on to vote. In rural areas without reliable connectivity, community centers set up voting stations with satellite links. Footage from around the world showed lines of people at libraries, schools, mosques, churches, and temples waiting to cast their votes. In Rio de Janeiro, samba dancers in feather costumes marched to the voting booths after a carnival rehearsal. In Paris, people sipped coffee at sidewalk cafes after voting, debating the pros and cons. In Karachi, volunteers distributed cold water to people waiting in the heat. In Sydney, a group of surfers voted at a kiosk on the beach, boards under their arms. In Moscow, a line wound around Red Square. In rural Alaska, a snowmobile brought a ballot box to a remote village. The UN live streamed turnout numbers like an election night broadcast. There were glitches, as expected. In some places, internet outages delayed voting. Conspiracy theories about hacking spread. The UN issued statements reassuring voters that multiple systems were in place to detect anomalies. A hotline was set up to help people with voting issues. Despite hiccups, the poll proceeded. The working group continued to refine their potential reply. They settled on a framework: 6 pulses to match the original, followed by a sequence encoding hydrogen and carbon again, then the number pi, then a simple pictogram representing a human, and a map of pulsars to indicate our location relative to well-known cosmic beacons. They debated whether to include the structure of DNA. Some argued that DNA is unique to Earth and could confuse an alien intelligence. Others pointed out that DNA encodes information through pairing and might be interpretable. In the end, they compromised. They would include a simple binary message describing paired units but not specifically DNA. They also decided not to include any information about Earth's resources, military capabilities, or vulnerability. The reply would be polite, inquisitive, and cautious. It's like saying hello and telling them we know basic math and physics, and here, S where we are, but please don't hurt us, quipped an artist. The group sent the draft to the UN, where legal teams reviewed it. We're writing humanity's cosmic greeting, Priya whispered to Tandu during a break. It feels surreal. Tandu nodded. It feels like we're writing poetry and a technical manual at the same time. Back on the streets, emotions ran high. In Johannesburg, a group of high school students created a dance inspired by the pulse pattern and performed it outside their polling station. In Beirut, a family hung a banner from their balcony that read, "Vote for our children's future." In Lima, an artist painted a mural of hands reaching towards stars. In Seoul, fans of Yi Park gathered outside a government building, holding candles and chanting for transparency. In San Francisco, protesters dressed as aliens demanding equal representation for extraterrestrials marched behind serious groups advocating for a reply. Meanwhile, in rural Pakistan, elders gathered under a tree and discussed the poll results they'd heard on the radio. "What does it matter?" one asked. "We will wake up tomorrow and the sun will rise." Another replied, "It matters because the world is talking together." In Madrid, a bartender surveyed his patrons. "So, are we replying?" he asked. "We are," replied a woman at the end of the bar. "I voted yes." The bartender smiled. "Let's hope they like tapas," he joked. Laughter erupted, cutting the tension. As voting closed, anticipation built. Screens in public squares across the globe displayed countdown clocks. In Times Square, New York, a massive screen showed a live feed from the UN headquarters. People pressed close to see. In Nairobi's Uhuru Park, families sat on blankets, children on shoulders. In Tokyo's Shibuya Crossing, commuters paused to glance at screens. In Lagos National Theatre, a crowd filled the plaza. Even in remote villages without screens, people listened to radios. Social media feeds flooded with votalians and Earth Decides. Pundits speculated about the outcome. "I think yes will win," said a sociologist on one channel. "I think no," countered a psychologist. "Fear is powerful." A pollster pointed out that younger voters were skewing yes. A climate scientist expressed concern that voting yes could distract from urgent Earth issues. A human rights activist argued that not replying could be seen as a failure to recognize a shared cosmic community. The debate raged until the final seconds ticked away. When the poll closed, the UN announced that results would be tabulated and verified using multiple independent systems. They promised transparency. The working group was placed on standby. Dr. D'Souza, Priya, and Dr. Liu found themselves waiting in a room with monitors, snacks, and a palpable sense of history. Priya texted her parents, "It's happening." Her mother replied with a heart emoji. Dr. Liu looked at a photo of his daughter on his phone. Dr. D'Souza took a deep breath and looked at her colleagues. "Whatever happens," she said, "we've done our best." On the streets, people chanted countdowns. 10, 9, 8 in a small home in Cairo, a family held hands. In a laboratory in Moscow, scientists paused their work. In a monastery in Tibet, monks rang bells. In Los Angeles, people clapped along with the countdown on TV. In Nairobi, a group of friends huddled around a smartphone. In a remote Antarctic research station, gloved hands gripped mugs of coffee as researchers watched the feed. Everywhere, hearts beat faster. The world had agreed to decide together on a question that transcended borders, languages, and histories. The UN Secretary-General appeared on screen. He thanked everyone for participating and acknowledged the imperfections of the poll. He reminded viewers that this was not legally binding, but would inform the next steps. He said that if the poll showed a clear majority, the UN would endorse the working group's reply proposal. Then he paused. He looked down at a sheet of paper, then back at the camera. "The results are as follows." The camera angle shifted to show the results board ready to update. The crowd in Times Square held its breath. In Nairobi, hands squeezed tighter. In Tokyo, commuters stopped mid-step. In London, protesters fell silent. The screen remained blank for a heartbeat. The music swelled and the feed froze. Technical glitch, gasps erupted. On social media, memes exploded instantly. Of course, the universe itself hit pause. The freeze lasted only seconds, but it felt like an eternity. The screen flickered back to life. The Secretary-General, slightly flustered, smiled apologetically. "My apologies," he said. "We were overloaded." He looked again at the paper. "The vote is..." Cut to black. A frozen frame on a live stream can hold an entire planet's breath. When the UN feed glitched at the moment, it was supposed to reveal the result of the global vote. Billions of viewers around the world screamed at their screens, pounded tables, and laughed nervously. Memes sprouted instantly. Even aliens hacked the vote. But the glitch lasted only seconds. The feed snapped back, the Secretary General composed himself, and with a small smile, he read the result. "The vote is yes." A murmur swept through Times Square and exploded into cheers. In Nairobi's Uhuru Park, people jumped up and hugged strangers. In Tokyo's Shibuya Crossing, commuters clapped and smiled at one another. Fireworks erupted over Lagos. In Moscow, people broke into applause, surprising even themselves. In remote villages where radio was the only medium, announcers translated the result, and cheers echoed across fields. The final tally, the Secretary General continued, was 73% in favor, 22% opposed, and 5% undecided. "Humanity has chosen to reply," he said. The UN would endorse the working group's reply proposal. The decision was not binding, but it gave moral authority to proceed. For the first time in history, a global referendum had been held on a cosmic question, and the answer was clear. The immediate reaction was a mixture of jubilation and relief. In Buenos Aires, a father lifted his daughter onto his shoulders and shouted, "We did it!" She squealed and waved a homemade flag with the 6 numbers drawn in glitter. In Cape Town, Tandia watched the announcement in the control room with her colleagues and burst into tears. Priya hugged her. "This is it," she whispered. "We're going to talk back." Dr. Liu stood quietly, hands clasped, eyes closed, as if in prayer. Dr. D'Souza felt a wave of emotion wash over her. The weight of the decision left her dizzy. She thought of the scientists who had dreamed of this moment decades before she was born. She thought of Yi Park and his manifesto. She thought of the 9-year-old girl's letter. She thought of the world coming together, even briefly, to answer the unknown. In Seoul, protesters carrying Yi Park's image wept and cheered. In Lagos, drums beat faster. In Berlin, people on both sides of the debate hugged, some in consolation, others in solidarity. Even those who voted no felt a strange calm. The decision had been made collectively, and they were part of it. Fear remained, but fear shared is less lonely. Not everyone celebrated. In Athens, members of Silence for Safety held candles and sang softly, mourning what they saw as a loss of caution. "We wanted time," one member said. "We wanted to think. We voted no, but we respect the outcome." In rural Russia, a group of elders shook their heads. "Fools," one muttered. "They will invite danger." In Cairo, a group of demonstrators burned a replica of the 6 numbers in protest. In Manila, a priest declared in his sermon that humanity had overstepped its bounds. Online, conspiracy theories proliferated. Some claimed the vote had been rigged by global elites. Others insisted that aliens had influenced the outcome. But even among skeptics, the sense of a shared moment lingered. One person wrote, "I voted no, but I'm proud that we decided together. That's something." Debate continued, but the focus now shifted from whether to reply to how. The working group reconvened in Geneva with urgency. They had a mandate and a tight timeline. The comet was moving away. A reply had to be transmitted, while 3IATLAS was still within range to receive a signal within its communication window. The group's composition remained diverse. Scientists, linguists, artists, philosophers, diplomats, and cultural representatives. Dr. D'Souza took the chair. She addressed the room. "We have been entrusted with crafting humanity's reply. It must be simple, universal, and respectful. We must assume nothing about the recipient's biology or culture. Triangulate our location." The group debated whether to replicate this exactly or to modify it to avoid being too specific. A radio astronomer pointed out that any civilization capable of detecting and decoding our message likely already knew our location, as the original signal had targeted us. "We have no anonymity," she said. "There is no hiding. Transparency is better." They decided to include a modified pulsar map with 8 pulsars and their periods encoded, representing a more general region without pinpointing Earth precisely. The hydrogen atom diagram that shows the hyperfine transition as a basic clock. two circles connected by a line would appear at the top, indicating that the hydrogen spin flip was the fundamental unit of time and frequency. Beneath it would be the 6 pulses matching the original message, then a sequence encoding the 21-centimeter hydrogen wavelength and the 12-centimeter carbon line, then the numbers pi and e encoded in binary, then the double helix and the human pictogram, and finally the pulsar map. The design would be repeated 3 times for redundancy. Once the design was final, engineers worked with software developers to translate the graphical elements into a sequence of radio pulses. They would modulate the amplitude and timing of the pulses to encode binary information. The pulses would be broadcast at the hydrogen line frequency of 1420, 405, 751 MHz, and the carbon line frequency of about 458 MHz, alternating between them to reflect the hydrogen-carbon theme. The entire message would last 73 seconds, the same duration as the famous WOW signal, a nod to SETI history. It would be repeated 3 times over the course of an hour, with 5-minute gaps between repetitions. The team rehearsed the encoding and decoding process. A test transmission was sent to a radio telescope in Australia to ensure the message could be received and decoded correctly. It worked. Tears and cheers erupted in the control room. The message was ready. Meanwhile, the UN General Assembly convened again to formalize the reply plan. Delegates took the floor to express support, reservations, or additional considerations. A delegate from a Pacific Island nation asked whether cultural symbols from indigenous peoples would be included. An artist on the working group responded that the human pictogram was intended to be generic, but that she had studied petroglyphs from multiple cultures for inspiration. A delegate from a South American country asked about including information about Earth's biodiversity. A biologist explained that while that was important, it would complicate the message and was better reserved for future communication if a dialogue ensued. A delegate from an Asian country asked whether the vote result was credible given uneven internet access. The Secretary General acknowledged the limitation, but emphasized that participation from all regions had been substantial. The Assembly voted overwhelmingly to endorse the reply plan. A resolution was passed. Humanity would send a reply to the 3IATLAS signal, as designed by the working group, via the Meerkat Array in South Africa and the Allen Telescope Array in the United States, under international supervision. Logistics moved quickly. The transmission sites were chosen for their powerful dishes and clear access to the necessary frequencies. Meerkat had detected the original signal's absorption features. It was fitting to send the reply from there. The Allen Telescope Array, long used for SETI, would provide redundancy. Engineers prepared the dishes. They calibrated the pointing, aligned the timing systems, and synchronized the transmitters. Software engineers loaded the pulse sequence into the modulation systems. Security was tight. Journalists were kept outside the facilities, though live feeds would show the transmission. In rural South Africa, locals were invited to watch from a nearby auditorium with a big screen. In Northern California, a similar gathering occurred. Dr. D'Souza, Priya, Dr. Liu, and other members of the working group split up to be at both sites. Yi Park's family, including Yumi, were invited to attend. They accepted. Yumi carried her postcard and looked around nervously. "I hope he sees this," she whispered to a friend. On transmission day, the world watched. The sun set over the Karoo Desert in South Africa as cameras panned over the Meerkat dishes, their white surfaces reflecting the orange glow. At the Allen Telescope Array, dusk also painted the horizon. Live commentators explained the setup in multiple languages. A countdown clock ticked in the corner of screens. In Times Square, thousands gathered again, wearing T-shirts with binary sequences. In Tokyo, the Shibuya screens displayed the feed. In Lagos, the National Theatre Plaza filled with people. In a small town in Saskatchewan, a family invited neighbors to watch on their projector. In Jerusalem, people gathered at the Western Wall, some praying, some watching on phones. In Mumbai, street food vendors did brisk business while their customers craned necks to see a portable TV. The whole world seemed to be holding its breath together. At T-10 minutes, Dr. D'Souza and her team stood before the console at Meerkat. Priya whispered, Are you ready? Dr. D'Souza nodded. She thought of all the hands that had prepared this moment. The scientists who detected the signal, the engineers who built the dishes, the philosophers who argued, the protesters who marched, the voters who clicked, the children who drew pictures. This was not just science, it was a symphony of humanity. At T-5, the cameras turned to Dr. Liu in California. He waved a hand. "Let's send some math," he said with a grin. A voice over the loudspeaker began the countdown. 10, 9, 8 in living rooms, bars, parks, and dorm rooms, people counted along. 7, 6, 5, Priya squeezed Dr. D'Souza's hand. 4, 3, 2, 1. Silence. The dishes began to hum with power. A green light on the console blinked to indicate that the transmitter was live. On monitors, a waveform traced the pulses as they left Earth. 6 pulses with prime numbers encoded. Then a pause. Then pulses encoding the hydrogen line. Then pulses for the carbon line. Then the digits of pi. Then the binary representation of paired sequences. Then the pulsar map. The pattern repeated. On screen, the message looked like a series of rectangles of varying lengths, neatly ordered. In the control rooms, no one spoke. Tears streamed down faces. Yi Park's sister held her hands to her mouth, tears in her eyes. In Times Square, the crowd erupted after the first sequence finished. "We did it!" someone shouted. In Lagos, drummers pounded in rhythm with the pulses. In Beijing, people lit lanterns and released them into the sky. In a mosque in Istanbul, after the pulses finished, a prayer leader recited, "God is the greatest." In Buenos Aires, tango dancers took to the streets. In Seoul, people chanted Yi Park's name. Around the world, fireworks burst, bells rang, horns honked, and people hugged strangers. Joy cascaded. The cameras cut to a wide shot of Earth from a satellite as the pulses traveled outward. Within a second, the signal passed the Moon's orbit. In 8 minutes, it reached Mars's orbit. In a few hours, it crossed the asteroid belt. It would reach 3IATLAS in just over 12 hours, long before our words could be intercepted by some hypothetical eavesdropper on Earth. But beyond that, the signal would continue outward at the speed of light, carrying our hello into interstellar space forever. Commentators explained the timeline. "In 73 seconds, we encoded human curiosity," one said. "In 12 hours, it will pass the comet. In 100 years, it will be 100 light years away, still traveling, still saying hello to any ears that might hear." The visual of a thin green line emanating from Earth into the blackness was both awe-inspiring and humbling. "We are but a small blue dot," another commentator quoted, "and now we have raised our hand." In the immediate aftermath, a strange calm settled. After the exhilaration of the broadcast, people grew quiet. In pubs in London, conversations turned to whispers. In classrooms in Tokyo, teachers let students sit in silence. In churches in Brazil, congregants knelt. On social media, hashtags slowed. Some posted, "Now we wait." Others wrote, "I can't believe we did that." A young woman in Lagos tweeted, "For the first time, I feel like a citizen of Earth, not just my country." A teenager in Moscow wrote, "I cried with my grandmother. We both felt the same thing, even though we voted differently." A philosopher posted, "We have sent our breath into the cosmos. Whether anyone hears it is less important than that we breathe together." Journalists interviewed those who had voted no. A man in Athens admitted, "I'm still scared, but my fear is less now that I know we decided together." In Seoul, a woman holding a candle for Yi Park said, "I hope he is somewhere listening." Governments, meanwhile, braced for unknown consequences. They established protocols for monitoring the comet and listening for any changes in the signal. They set up committees to handle hypothetical responses. They allocated funding for new research into communication technology, advanced encryption, and psychological readiness for contact. A small subgroup was tasked with planning what to do if the reply drew attention from other, unknown sources. At the Pentagon, analysts updated contingency scenarios. At the European Space Agency, engineers proposed building a dedicated receiver for interstellar replies. At the China National Space Administration, officials debated launching a probe to follow 3IATLAS after it left the inner solar system. "We need to go to them," a Chinese scientist said. Elsewhere, the post-vote world looked much like the day before: work, school, traffic, meals. Humans remained creatures of routine even in extraordinary times. The missing engineer's saga found resolution in the days that followed. A video appeared on an encrypted platform. In it, a man whose face was shadowed spoke. His voice matched Yi Park's. He confirmed that he had leaked the data and that he had sent the emails and postcards to his sister. "I never intended to put anyone in danger," he said. "I believed humanity had a right to know. I'm sorry if I caused fear. I'm proud of what we did. I will remain hidden because I trust my colleagues to continue the work." He did not reveal his location. Governments vowed to investigate, but there was little appetite for punishment. Public sentiment saw him as a whistleblower. Yumi released a statement thanking the world for supporting her brother. "We miss him," she wrote. "We hope he sees that his actions mattered." Priya, upon watching the video, felt a mix of anger and admiration. "He risked a lot," she said. "He forced us to confront our fear and our curiosity. He made this possible." Dr. Liu nodded. "Heroes are complicated," he said. "So are scientists." As the dust settled, philosophers returned to broader questions. Essays appeared. One argued that the reply was humanity's first act of cosmic diplomacy. Another contended that the vote and reply reflected a species struggling to unify, and that this struggle was more important than any answer from beyond. A sociologist wrote that even if no aliens ever responded, the process of decoding and replying had changed Earth. It had inspired cooperation across nations, disciplines, and cultures. A theologian pondered the spiritual implications. If we hear nothing, will we interpret silence as indifference or as patience? If we hear back, will we interpret it as salvation or as test? A novelist wrote a speculative piece, imagining an alien child receiving our message and wondering at the creatures who sent it. People debated whether we had acted wisely or foolishly. But the tone had shifted. Fear had not disappeared, but awe had grown. Curiosity had proven stronger. "We have chosen to be known," wrote a journalist. "Now we must decide who we will be when someone answers." The global community instituted a new annual tradition called Reply Day. Schools held assemblies, where children wrote messages they would send to aliens and sealed them in time capsules. Cities held concerts featuring music inspired by prime numbers and hydrogen lines. Religious institutions offered prayers. Scientists gave public talks about astrobiology. Museums opened exhibits on communication, ancient, modern, and extraterrestrial. The first Reply Day was joyous, but subsequent ones were more contemplative. The tradition served as a reminder that humanity had stepped onto a larger stage, even if no one else was watching yet. It also served as a gauge of patience. "How long do we wait?" a child asked at a Reply Day event in Toronto. "A lifetime, 1,000 years," the presenter replied. "We wait as long as we have patience. We wait because listening is part of who we are now." Years passed. The comet continued its journey. Its signal faded from media headlines but remained in scientific journals. New discoveries, crises, and celebrations came and went. The reply we sent traveled outward, carrying our greeting. In remote observatories, radio astronomers continued to listen. They recalibrated equipment, filtered noise, and occasionally caught tantalizing anomalies, false alarms that made hearts race and then sink. At night, people still occasionally looked up and thought about the message. Teachers told the story to new students. The 9-year-old girl who had written the letter grew up to be a scientist. She gave a talk titled, "How I Fell in Love with the Universe," crediting the moment humanity replied to the signal. Yi Park's sister became an advocate for scientific openness. Priya traveled the world giving lectures on ethics and astrobiology. Dr. Liu retired, his eyes still scanning the sky every evening. Dr. D'Souza continued to work on SETI, her name synonymous with the Great Reply. The world had not ended, nor had it been transformed overnight, but it had shifted. A seed of cosmic awareness had been planted. We end our story with a final visual. The camera pulls back from Earth, zooming past the orbit of the Moon, past Mars, past Jupiter's swirling storms, past the icy rings of Saturn, past the edge of the solar system, and into interstellar space. The faint green line of our reply continues outward, intersecting with the trail of 3IATLAS, then moving beyond. The original message from the comet still pulses, faint but steady. Perhaps someone somewhere hears it. Perhaps not. the narrator speaks softly. We ask the universe a question not because we expected an answer, but because asking is who we are. In the silence after our answer, we listen not just for aliens, but for echoes of ourselves. The search has never been solely about them. It has always been about us, what we hope, what we fear, and how we choose to act when faced with the unknown. Thank you for staying with me on this journey. Remember to look up, to wonder, and to listen. This is not the end, it is a beginning. We've come a long way from the first whispers of an interstellar anomaly. At the outset, the discovery of 3IATLAS seemed like another curiosity in the night sky, one more icy visitor from deep space. Then came the signal. 6 repeating numbers pulsing on the hydrogen line, the universal frequency of the cosmos. We watched as scientists struggled to verify the data, comparing it with the fleeting WOW signal from 1977. We learned why 420 MHz matters, that neutral hydrogen emits at that frequency, and that any civilization looking outward would know to listen there. We explored the lonely history of interstellar comets and debated the provocative speculation that 3IATLAS could be something other than ice and rock. We witnessed the methodical process of verification, multiple observatories confirming that the pulses moved with the comet, ruling out satellites, airplanes, and earthly interference. We watched the story of a young engineer, Yi Park, whose keen eye caught a pattern and whose abrupt disappearance added mystery and human stakes. We saw the global reaction explode after the data leaked. Conspiracy theories, memes, government denials, scientific papers, protests, and earnest letters from children. We watched debates about ethics, safety, and curiosity, and we saw how different cultures interpreted the cosmic whisper through the lenses of religion, philosophy, and history. We saw a scientist cry with relief and a politician tremble with fear. We decoded the message's deeper layers. The 6 numbers hinted at hydrogen and carbon, the building blocks of life. We speculated that the senders were establishing a shared scientific vocabulary. We marveled at the possibility that someone had aimed a signal across hundreds or thousands of light years to reach us precisely when we had the technology to hear it. We saw a map of the Milky Way and understood the scale of interstellar distances. We sat in silence with farmers, prisoners, children, and elders as they stared at the night sky and felt small and connected. We debated whether to reply. The updated post-detection protocols advised caution. Military advisors warned of cosmic predators. Scientists urged the honor of curiosity. Philosophers asked who had the right to speak for Earth. The Missing Engineers Manifesto fanned the flames of public protest. A global poll asked a simple question: should we answer? Despite fears and imperfections, humanity decided yes. We wrote a reply rooted in universals. Prime numbers, hydrogen and carbon lines, mathematical constants, a simple human figure, a pulsar map, encoded it into pulses and sent it out through radio dishes pointing at 3IATLAS and beyond. We watched our greeting ripple into the void. We cried and cheered together. We waited. In telling this story, we discovered that the cosmos is not just out there, it lives in the spaces between us. The act of listening for a signal from another world forced us to listen to each other. Scientists collaborated across borders. Ordinary people debated ethics with philosophers. Governments consulted artists and mathematicians. A missing engineer's sister found her voice. A 9-year-old girl's letter became a symbol of innocence and hope. Street protesters and heads of state engaged on the same question. In wrestling with the unknown, we learned who we are when we are at our best. Curious, cautious, creative, contentious, and above all, connected. There are still unknowns. We don't know if we decoded the message correctly or if there are deeper layers we missed. We don't know who sent it, from where or why. We don't know if our reply will be heard or if it will join countless unreceived whispers drifting through the galaxy. We don't know what the risks are, and we can't predict the future. But we do know that sending the reply changed us. It expanded our perspective. It compelled us to consider ourselves a single species, at least for a moment. It reminded us that our planet is a pale blue dot shared by 8 billion unique souls who can, when asked, make a collective choice. The final emotional beat is not one of triumph or terror, but of humility. We looked up at the night sky and realized that the universe is vast and indifferent, yet we are